So in this video, guess what? Yeah, you got it right. We're doing more examples. I told you, I'm the example king, and we're going to keep doing these examples over and over until I know that you feel comfortable with this nomenclature lesson. All right, so here's an example. It's going to say, draw and label the E and Z isomer, if any, of the following molecule. All right, so there we go. So it's going to be our job to just draw the E and Z form. It doesn't say anything about name. We can go through and name it. We'll do that last, and we'll do that as an extra oomph to the example problem. But here we're just going to draw the E and Z isomer. That's it. All right, so just like before, I'm going to focus on the C double bond carbons. All right, so C double bond carbons are right there. And I know that each one of these have legs that poke out like this. And on the left-hand carbon, I have this ethyl group, CH3CH2, that's attached to it. And I also have that hydrogen that's written there as well. So it doesn't really matter. I'm going to have to provide both if there is one. So there we go. All right, so we'll figure out the rest of it a little bit later, but now my focus is on the second carbon. So on the second carbon on the right-hand side, I also see a hydrogen that's listed, and I also see a methyl group that's listed. So I'll just draw it that way. So now I need to figure out, does this have E or Z? Okay, that's the thing here. So you're going to look at this and you're going to say, hey, over here on the left-hand side, we have a high priority group, and I've got to figure out what that high priority group is. So this is a carbon that's directly attached to that one, and then this is a hydrogen that's directly attached to that carbon. Well, out of these two, carbon has the highest atomic number. So therefore, this would get the highest priority group. Over here on the right-hand side, we see something very similar. We see a carbon directly attached to that one, and we see a hydrogen directly attached to that one. Out of the two, carbon has the highest atomic number, so therefore this one has the highest priority group. And you would look at these groups and you would say they're on the opposite side. And because they are on the opposite side, you would tell me that this was E, because they are not on the same side, right? So this is the E grouping system. Okay, so here's the thing. Maybe, just maybe, at the beginning of this example, you were like, this is not really E or Z. And the reason is because the left-handed carbon had a hydrogen on it, and the right-handed carbon had a hydrogen on it. So by default, shouldn't we use cis or trans? Because the hydrogens are on opposite sides here. And if they're on the opposite sides, then we should be using trans for the name and not E for the name, right? Well, here's the answer to that question. The answer to that question is either. Cis and trans is becoming somewhat outdated. And cis and trans is kind of how all of this got started. Cis and trans people still use today just like a common name, and we still use cis and trans whenever possible. But folks, here's really the take-home message of this. E and Z are great for high priority groups that are not hydrogen, but it also works with hydrogens on those carbons just like it did in this example. So if I said E, I would be correct. And if I said trans, I would also be correct. Either one of those are actually acceptable in the world of organic. The E and Z are for really the newcomers. Okay, the newcomers to the field. E and Z will work with most every single thing, every single double bond that we have. And because of that, it's a surefire way to make sure that it does work versus cis and trans that really only works for hydrogen groups, and that's it. So the question tells me to draw both. All right, so my voice is going out. I've been talking too much. All right. Over here on the right-hand side, I'll just flip that around, and I'll put the CH3 there, and I'll put the hydrogen there. So high priority group is right here. High priority group is right there, just like before. Z groups are on Z same side, so therefore this is the Z form. However, it would also be called the cis form because I do have these hydrogens, and those hydrogens, one on each carbon to the left and to the right, and those hydrogens are pointed in the same direction. So those are also regarded as cis. Either one of those will work, but it does have an acceptable E, and it also does have an acceptable Z. Now, what about the name, right? I told you this was going to be extra, so we can name this thing 1, 2, 3, 4, 5. So this is a pentene, and I got to tell you where the ene is at. It looks like the double bond is going to be closer to the right-hand side. That way it can give a lower number. So this is a 2-pentene. So this is the name of this structure, and I have no clue if that's E or Z the way that that's drawn, and that's just the name that I would provide you, 2-pentene. However, these molecules down here, the way that they're depicted, I can give you that form. This is going to be the E2-pentene, and this is going to be the Z2-pentene. All right, so there we go. Only one double bond, so I don't have to put a number here unless I absolutely want to, and it's not going to hurt you if you do. So if you do put a 2 there and you do put a 2 there, to let me know that that does go with the double bond at spot 2 as almost like a confirmation type of thing, you're more than welcome to do that. And then the E's and Z's normally go in parentheses. If you do not put them in parentheses, no big deal. I'm not going to count it wrong, folks. I told you time and time again, this is something that I'm perfectly okay with, so I'm not that picky. All right, so let's do another example. This time, let's draw the form of E, 1 bromo, 2 methyl, 2 butane. All right, so it gives me a name this time. And now I have to draw the structure. I'm working backward a little bit, aren't I? So this is no more complicated. What I normally like to do, though, I like to start with a normal structure first, and I pretend like that E is not there. So I go through and I just scribble out the structure of the main component, and then I'll worry about the 3D orientation a little bit later. So 1 bromo, 2 methyl, 2 butane. All right, butane is 4. So 1, 2, 3, and 4. And on the second carbon, I have the ene group. That's how I interpret that, right? So on the second carbon, I have the ene group. There we go. On the second carbon, I also have a methyl group, so I'll put that there. And then on the first carbon, I have a bromo group, so I'll just draw it that way. I could draw it out to the left if I wanted. It's still attached to the first carbon, isn't it? So it doesn't really matter. So now I need to make sure that I draw the E form of this structure. So this is the template. This is where I'm going to start. And I need to convert that type of structure over to something that looks a little bit more like this. And I have to make sure that these are E. So E, I'm going to scribble over here to the side, means opposite, right? Opposite sides. Z groups are on Z same side. So E is the opposite side. All right, so on the left-handed carbon, what kind of groups do I have? Well, it looks like I've got a methyl group. All right, so I'll draw another carbon. And it also looks like I have a carbon with a bromine on it. So a carbon and then a bromine off of that one. So there's the setup. And then over on the right-hand side, it looks like I have a carbon and something, a fourth bond that's not drawn, and that's understood to be a hydrogen. So I have a carbon and a hydrogen over here. Before I do this, though, I'm going to take a look at my left hand, so that way I don't waste time. I want to look at the left-handed carbon, and I want to rank these priorities. So I go immediately to that carbon, carbon, and carbon. This is a tie. These are directly attached to that carbon to the left. So I move on to the next. When I move on to the next one, well, I run out of choices up here at the top, don't I? There's nothing else left for me to choose from unless you just want to count the hydrogen. And then down here at the bottom, I move on to the bromine. So I know that this is going to be the highest priority group down here. So over here on the right-hand side, I need to make sure that my highest priority group is up on top. This way, it can be the opposite of, and it can give me the E, and I'm not wasting time and drawing structures that I don't need for the problem. So over on the right-hand side, what groups do I have? I have a methyl group, and I have a hydrogen. Out of those two, carbon has a higher atomic number than hydrogen does. Therefore, carbon has the highest priority, which means that carbon better go up there at the top. And then here is the hydrogen that sits down below. This way, this is the highest priority group up here. They are opposite of each other, and that's what the molecule wants. It wants the E form, and that is what I've just given it. All right, now I'm going to make this a little bit better, okay? I've shorthanded every single bit of what we've done, and sometimes they like for you to give all of the hydrogens that are on that molecule. So up here at the top, I know that that is a carbon with 3 hydrogens to make that a methyl group. Here at the top, I know that's carbon with 3 hydrogens. There's a methyl group. This hydrogen down here at the bottom right, that one's perfectly okay. There's nothing else that's needed there. However, to the left, this carbon needs 2 hydrogens there because 1 bond is to the carbon and 1 bond is to the bromine, and it needs 2 more. So those 2 are going to come from hydrogen. So this is a little bit more complete. All right, I could do the same thing up here. Right? I could fill in H's there. I could fill in H's here. I could fill in the hydrogen that's there. And then here, I could also fill in the CH2s that are going to be there. So this is really just a personal preference. Sometimes people like it, sometimes people don't. But there we go. If I was drawing this as a skeletal structure, I could do that as well. There's my double bond. So here, I have a methyl group. There, I have a methyl group. Here I have a hydrogen, but sometimes we want to draw that hydrogen so you do not confuse that with a carbon. And then here I've got a carbon, and off of that carbon I have a bromine. So I have to write that one at least. So there's the skeletal representation of what we've just done. Again, it begins to wrap up all of these lecture materials that we've talked about in the previous example problems. All right, so let's do another one. We'll do another one. It's okay. We'll do another one. Z, parentheses, 3, isopropyl, and 2, heptene. All right, so just like before, I'm going to start off with my main carbon chain, and that's heptene. So hept is 7. 1, 2, 3, 4, 5, 6, and 7. On carbon 2, that's where my double bond is at. So 1, 2, and there's a double bond. On carbon number 3, I have an isopropyl group. So here is the carbon and a carbon and a carbon. There's my L, there's the isopropyl, right? And I've got the freedom to draw it that way. Not a big deal. But now I have to represent it as a Z form. All right, so down here at the bottom, I'm going to do carbon, double bond, carbon, and I'll draw the legs. There we go. And then to the left, I see that carbon is attached to another carbon, and that 4th bond that's not drawn is to a hydrogen. So there we go. And over on the right-hand side, I see an isopropyl group as one of the attachments. And then I also see a butyl group that is one of the attachments. So before I go further, I need to make sure that I'm going to end up with the Z form. And the Z form means the same side. Okay? So over on the left, carbon outdoes hydrogen. It has a higher atomic number. So this is the highest group number right there. So I'm going to circle it. And that way, when I put the substituents on the right-handed carbon, I'll know which one needs to go toward the top, because that would be my highest priority group, and that allows them to be on the same side. So out of these two, I've got a carbon and a carbon. Well, that's a tie. I move on to the next. That's a carbon, it's a tie. I move on to the next. Keep in mind, I told you, it's the longest chain. You can't kind of go backward. So after this point, I'll run out, and then here I don't. I have another carbon. So this butyl group is going to be the highest priority group. So because of that, I'm going to draw my 1, 2, 3, 4 carbon piece up here at the top, and then here I'll draw the isopropyl group that is there. So this will give me the highest priority groups, both pointed to the top in this example, and that will give me Z. Folks, here's the other story I don't want you to forget. If you drew the carbon down at the bottom, and you drew the butyl group also down at the bottom, they're still on the same side, aren't they? So that would still be the Z form, and that is still a correct answer. I've just kind of flipped the molecule around. That's all that I've done. So either way that you end up with this, as long as that methyl group and the butyl group has ended up on the same side, then you're good to go. All right? So there's the Z form of 3-isopropyl 2-heptene. Let's do this skeletal-wise. Here's my double bond. Here I've got a methyl group, and I'm going to draw a hydrogen there just so you don't confuse it with a carbon. Up here at the top, I have a butyl. So there's 1, there's 2, there's 3, and there's 4. And down here at the bottom, I have an isopropyl. So there's 1, there's 2, and there's 3. And that is how we would draw this in a skeletal form. All right, so hopefully these are getting a little bit more comfortable for you. And maybe, just maybe, you're looking back at that previous lecture module and you're saying, you know what? This wasn't too bad now. And why was it so bad when we did module 3? Well, that's typically because that's the first time that you've seen it. And now what's happened is that we've done more and more and more and more examples using very similar rules to Module 3, and all of this is starting to blend again. So you're getting more comfortable with the material. That's what's going on. All right, so problem 11. Let's look at this one. Draw and label the E and the Z isomer for each of the following. Oh my gosh. Look at C and D. What on earth? Those aren't bad. Those really aren't bad. So don't freak out on me. But we're going to work through all of these examples. And it does want me to draw and label the E and the Z form both. So this is going to take a little bit of time. But you know what? I'm going to go through these a little bit quicker because I think that you can handle it at this point. So CH3, CH2, CH, double bond, CH, CH3. All right, here's my double bond, C double bond there. There's my legs. Over here to the left-hand side, this carbon, well, it's got an ethyl group on it, CH2, CH3, and it has a hydrogen. There we go. Over on the right-hand side, I've got this carbon. So that carbon has a methyl group on it, and that carbon also has a hydrogen on it. There we go. Well, what did I just draw? I have to do both. That's why I didn't think about it. So this is a higher priority group. Carbon beats hydrogen. This is a high priority group. Carbon beats hydrogen. Therefore, Z groups are on Z same side, and there is the Z form of that molecule. Well, it also wants the E form, doesn't it? This is pretty easy once you get one of them. Keep one side the same. I normally keep the left-hand side untouched and flip the other side around. So there we go. This is the high priority group to the left. This is the high priority group to the right. And therefore, this now is the E form to that molecule. Do you see how easy and smooth that was? That's how these should start becoming. All right. So in addition, these carbons, they also have hydrogens, don't they? This has one hydrogen on the left. This has one hydrogen on the right. I could use cis and trans to name these. That's not a problem. And I could use this same example and I could say, name this as cis or name this as trans, and you would be able to do it. And it's these compounds that sometimes cause people problems. But they shouldn't cause you a problem because these compounds are very versatile. They can do cis trans or EZ, either one, and you need to be okay with that. All right, so part B, we've got CH3, CH2, carbon, double bond, carbon with a hydrogen, CH2, CH3, and off of this first double bonded carbon, I have a chlorine. So they tell me, do the E and the Z form both. All right, not a big deal. Carbon, double bonded carbon, I draw the legs. This carbon to the left, what does it have on it? It has the ethyl group piece, CH3, CH2, and it also has that chlorine. Well, that's the way that I'll put it there. I don't need to think about it. I need to provide both. Over here on the right-hand side, there's the right-handed carbon. Well, what do we have attached to it? I have a hydrogen on it, and I also have a CH2CH3. Okay, so that's just the way I'll load it up. Now I need to go back and take a look at the high priority groups. So here I've got a carbon that's directly attached, and here I have a chlorine that's directly attached. Okay, so out of those two choices, chlorine has the highest atomic number, so therefore that is the highest priority group. Over here on the right-hand side, I've got a hydrogen and I've got a carbon. Carbon has a higher atomic number, that gets a high priority group. So these groups are on the same side, therefore this is the Z form of that molecule. To do the E, it's pretty simple. Just like before, I keep one side the same, CH3, CH2, and the chlorine down below, and I flip the other side of the molecule, CH2, CH3, with a hydrogen here. If I just double check myself, the high priority group on the left, still chlorine, that has the highest atomic number. The highest priority group on the right, it's a carbon still. There we go. And these are on opposite sides, which makes this the E form of that molecule. All right. Okay, so let's do part C. Part C was a pretty nasty looking one. All right, this is how they've drawn it. They did a carbon, double bond, carbon. And here they kind of went up and they did CH2 and CH2 and CH2 and CH3. And then over here to the side, they did CH2 and CH3. And over here on the right-handed carbon, they did CH2 and a Cl. And then down here, they did a CH with a CH3 and a CH3 on each side. Oh, gosh. Do they want me to name it? No, but we could. We could actually name this without a problem. Okay, so let's do the E and let's do the Z. It doesn't really matter which one. I got to give both, right? So over here to the left, carbon, double bond carbon, ding, 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 ding. There's the legs. All right, so over here on this carbon, I've got two different types of groups. I've got a butyl group up here at the top, and I have an ethyl group that sits down below. It doesn't really matter. I need both, so let's just slap them on here. It doesn't really matter where they go. So there's my butyl group, and then here is my ethyl group. There we go. The side is now done. I don't really have to worry about that. I'll move on to my next. All right, so the other carbon in the double bonds here. What's attached there? Well, it looks like a CH2 and a Cl, and then it also looks like this isopropyl group, right? So the CH with a CH3 and a CH3 that points down. There's the isopropyl group that's drawn in that diagram. So I've got to figure out, what did I just do? Yes, we took organic. I know that's what you just did. But what did we just draw down? Okay. All right. So on the sheet of paper, this carbon and that carbon is a tie. I move to the next one. That carbon is a tie. We move to the next one. This carbon and that runs out. So this is the highest priority group up here at the very top. I'll circle that one. Over here to this side, there's a carbon, it's a tie. I move on to the next. Well, it doesn't really matter how I go. Let's just go across. Here's a carbon and there's a chlorine. Well, chlorine beats out that carbon, so therefore this is the highest priority group up here at the top. Z groups are on Z same side, so therefore this is the Z form of that molecule. Folks, that's how we do this. It looked ugly, it looked nasty, but guess what? It was no more difficult than the others, was it? As long as we followed the rules. So now I need to draw the E form. Again, I keep the left-hand side the same. That's just me. If you want to flip it, flip it. Nobody's going to care. And then over on the right-hand side, that's the one that I like to flip. All right, so CH, CH3, CH3, and then down here at the bottom, CH2, Cl. Once again, my groups are on opposite sides at this point, and that gives me an E form of the structure. So you flip whatever side that you want to flip, just don't flip it off, and don't flip me off either for introducing you to this material, okay? So there's the Z, and there's the E. All right, so we've got one more. Let me just show you what D looks like. There's D. Oh, gosh. What on earth do they want me to do? So I need to look at my double bond. And right here is the double bond that we need to focus on, okay? So this double bond area is where I'm going to start. So, clean sheet of paper, I'm not going to redraw that horrible mess. So I'm just going to go straight to this kind of template right there. All right, if I go back to the example problem, it looks like this carbon has a CH double bond O on it. Okay, so that looks pretty easy. I'll start there. CH double bond O. Okay, so what's the other group that's on it? CH2, CH2OH. All right, so up here at the top, we'll do CH2, CH2, and OH. All right, next. Over here to the right-handed side, I see a carbon triple bond to a carbon. We've not really seen that before, have we? That's a new one. Carbon triple bond to a carbon. And then down below, I see a carbon with 3 methyl groups. Oh, have we really seen that before? Yeah, we have. It's just been a while. There's one methyl group, there's another methyl group, and here's another methyl group. That's a tert-butyl group, people, right? It's a tertiary carbon, and there's 4 in total. So they want me to rank these? The answer is yeah, it's going to be pretty easy. Watch this. That carbon and that carbon, ding, tie. I move on to the next. This carbon and that oxygen. Oh, oxygen beats it out. So this is the high priority group. I don't need to look for anything else. I've already determined what that was. All right, the next one. This carbon and that carbon, ding, tie. The next one, we have a carbon, and it doesn't really matter which way I go. I mean, it's the same in whatever direction. So let's just go down here. There's a carbon that's in next. There's a carbon that's next. So ding, that's a tie. And then this is a triple bond. So I would count this carbon again. So there's a new carbon, and we run out of a long length here, don't we? And because of that, we kind of divert back to hydrogen. And that forces this group up here to be the high priority group. If that was another tie, we would count this carbon a second time before moving on to the next because it has a triple bond on it, not a double bond like we've seen before in the past. So here's the high priority group on the right. There's the high priority group on the left. They are on opposite sides, so this would be E. And in order for me to draw the Z, well, just to prove a point, I'm going to flip the left-hand side to let you know that it's okay to do that. Don't feel weird if you decide that you like the left-handed side better than the right-handed side. All right, so I'm just going to keep the right-handed side the same this time. So there we go. This is my high priority group. This one is my high priority group. Therefore, this is the Z form of that molecule. All right, so we've just done that horrible example problem. It looked horrible in the beginning, didn't it? Especially part C and part D. There was a lot of things that were going on, but we just took our time, and we used the rules of IUPAC, and we did one atom at a time and compared them, and you saw really, hopefully, that it was no more complicated than some of the others. There was just a lot more stuff that I had to write down for those problems. So my hand did not like it, but my mind was okay with it. And sometimes that's all right. Okay, so in the next video, we'll pick up from here. We're not done with Z or E yet. There's still some more examples that I would like to do with you, and this is going from skeletal structures to names based on how they've drawn the skeletal structures. So with that said, this is where we'll stop. Next video we'll pick up. We'll do another video of example problems, maybe 3 or 4 in total, and then we'll move on to our next lecture topic of the chapter.